All right, let's take a look at problem 2-6. So let's click over here. Let me drag this out of the way a second here. So here's what we're looking at. I can zoom out a little bit so we can see it. So vapor pressure data, CO2 given below, estimate vapor pressure for carbon dioxide at 40 degrees Fahrenheit. So when we start seeing vapor pressure stuff, your mind should go towards the Cox chart. I'll write that down here, Cox chart. And Cox chart, if you remember correctly, is log of the vapor pressure versus 1 over temperature. That's in Rankine, if you remember. So if we take these points that we got here and plot them, it should look like some kind of line. And we want to do a curve fit on that line, and then we'll come out. We'll be able to predict anything we want using the old rise over run. Here's your rise. Here's your run. Just using some basic algebra. So what we're ultimately looking for is log PV equals to some slope times 1 over T plus B. So we need to solve for this M and B. M, if you remember, is going to be the rise. So if we do it like this over run, and then we can solve for B the same way. Once you know this, you can solve for B by doing whatever log of some vapor pressure minus M times 1 over some temperature, right? So we solve for these two guys, and then we can come back, plug it back in the equation, and come up with our answer. So I thought the quickest way to do this would be to put it in Excel. So I went ahead and put the values in from the table. Here's our temperature and here's our pressure. So if you want to come, first thing we need to do is calculate this in Rankine. So the way you translate that is Fahrenheit plus 460 is going to give us Rankine. So I can go ahead and put that in. Plus 460. So 420 Rankine. Then I can copy those cells down. That gives us nice values. Now I need to do 1, because this is 1 over T, right? And it's 1 over the absolute temperature. So 1 divided by, so that gives us the inverse. Drag that down, so now I've got all that. And this one is the log. So log is easy enough. Log of pressure. So now I've got all of these solved out. Now, what next? I need to be able to calculate for M. So I can do, let's see, if we want to call rise, I can make rise be this value minus that value. And I can make the run equal to this value minus that. And then give me my slope M. That's equal to rise divided by run, right? And now B, I need to calculate the B value. So B, I'm going to take this value, just throw 1 in the middle. So B minus M times this value. And that gives us, oop, I did something wrong. Oh, it's not supposed to be that value. It's supposed to be, we can drag that over. It's supposed to be that value. There we go. That looks right to me. And now we want to make a new prediction. So our prediction is at 40. That's what our question is saying, 40 Fahrenheit. So I can copy this cell down and copy this cell down and give us our values. Now I need to calculate this. I can calculate that with this equation now. So I can put equals 2 m times the 1 over t value plus the b value. Boom. There we go. And now this guy should equal to 10. The inverse of the log base 10 is 10 to the power. So 10 to the power of this gives our answer, 570. So there's the answer to our problem. Now the other thing you can do, drag this out a little bit, is we can actually plot these values. Let's insert a scatter plot. There we go. Let me zoom out a little bit so you can see it. So here's the values. This is the one we just predicted, actually. So if we wanted to come back and pretend like we didn't have that yet, there we go. So here's our log pressure. Here's our 1 over temperature. We can actually do a trend line. We can add a linear trend line, display equation. We can show r squared if we want to see that. So here's that value. So this should look somewhat similar to the values that let me close that, to the values that we got, and it's close. Minus, there's a slight difference because round off error, and this is pretty close to the value we got. So there's two different ways you can get that. You can calculate it manually or use Excel to be able to calculate that. But here's our answer. So our answer to this problem would be vapor pressure equals basically 571 psi A. Oops, come on, focus. I don't know why it came out. Oh well. There's your answer. There we go.